Have you ever wondered, why does this problem always seem to appear again? Or, why doesn't this improvement seem to stick? In this module, we will look at one of the most important things you can do to make improvements stick: standard work. Standard work is a detailed definition of the current agreed-upon steps needed for a person to complete one work cycle in the absolute best and most reliable method possible. It goes without saying, but when improvements occur, it is important to standardize the improvements. Without new standards in place, it is very likely that the process will slip back into the way it's always been done before. In the just-in-time system, it is absolutely essential that you have standards in place. Taiichi Ono once shared, "Where there is no standard, there can be no Kaizen." This is true in the sense that improvements are only a figment of our imagination if we don't have somewhere to start or a baseline to measure from. As such, each process in a pull system depends on both the suppliers and customers in a process to deliver the right product at the right time and in the right amount. Without this, pull systems and the just-in-time system simply would not work. One way that a company can begin to establish standards and stable processes is to begin with standard work. Standard work makes it possible for processes to be measured, and it makes it much easier to improve upon. You may hear standard work referred to as standard operations or even work standards. Whatever the case, standard work has three main pieces in the standard work puzzle: tack time, standard sequences of work or standard work sequences, and standard in-process inventory, or standard work in progress. Another important measurement to keep in mind once your tack time has been established is your cycle time. While this isn't a main piece of the standard work puzzle, you will at some point need to understand how your current cycle time compares to your tack time. We will introduce cycle time along with the other three pieces of the standard work puzzle in upcoming lectures. Now, before we go, let's stretch our minds again. You can answer the following questions in the comments section, upcoming assignments section, or on a piece of paper at your desk. What do you think? Do you agree with Taiichi Ono's statement? And why? We look forward to the discussions that may start and the interaction that's possible as you answer these questions. We'll see you in the next module. First, and arguably most important element of standard work is tack time. The purpose of tack time is to solve an age-old problem and match production with demand. It is often referred to as the heartbeat of a lean production system, and so it is also with standard work. Tack time refers to the rate at which products, information, and/or services need to be completed in to keep up with customer demand. Much like the pulse of a heart rate, tack time tells us whether we are beating at a healthy rate or we are falling dangerously behind. Tack time is a calculation that divides the available production time by the customer demand. Here's an example. If a factory operates for a standard 8-hour workday, or 480 minutes per day, and their customer demand is 240 parts per day, the tack time would be 2 minutes per part. As you can see, tack time attempts to match production with the required customer demand. Tack time is essential in setting standard work because it sets the pace that operations need to produce at in order to keep up with customer demand. This is different from cycle time. Cycle time is the amount of time it takes to complete an individual operation or task from start to finish. In other words, cycle time is the time required, and takt time is the demanded time. Another way of looking at it is that cycle time is your current state, and takt time is the goal. As you strip waste from a process and draw down your cycle times, the goal is to meet the customer's takt time. Here's an example. Let's say you establish some standard work, and the operator's current cycle time is 4 minutes, but your takt time is 2 minutes. We would need to review the process and look for ways to remove waste that may be slowing the process down and speed the process up. Now that you have an understanding of what takt time is, let's test our new knowledge out. Let's say you work at a factory and you work a standard 8-hour day, or 480 minutes. Your customer demand is 120 parts per day. What is your takt time? You can answer the question in the comments section, upcoming assignment section, or on a piece of paper at your desk. We look forward to hearing back from you, and we'll see you in the next module. Standard work is a detailed definition of the current agreed-upon steps needed for a person to complete one work cycle in the absolute best and most reliable method possible. It is made up of a few different elements, one of them being the element of standard work sequences. People cannot perform or achieve standard work without having a regular, standard work sequence. In this lecture, we will answer the question, what is a standard work sequence or work sequence? Work sequence is the order in which work is performed. The work sequence is generally made up of the best possible method of performing a task or producing a product. Work sequences should be established with the absolute minimum amount of waste in the sequence. A simple way to remember what a work sequence is that it is the order in which tasks are completed. You may hear a work sequence also called the sequence of operations. Many times a work sequence begins as a very logical sequence of steps. As time goes on, and through small and simple improvements that should occur, the work sequence should progress towards an ideal state. Let's look at an example of a work sequence. Let's say K&K cooks eggs for a customer. The work sequence is the steps necessary to make the eggs. It looks like this. First, you retrieve the raw materials. Next, you gather your tools. After that, you crack your eggs, then mix your ingredients. Cook, and finally enjoy your eggs. As you can see, these steps document a sequence for cooking eggs. Of course, this is a logical sequence and could have more detail and improvements added to it. Nonetheless, the work sequence can be repeatedly performed. A well-designed process will have materials and tools situated at or close to the point of use. It will also create an efficient flow of work. Documenting a standard work sequence or the steps needed helps ensure that times are consistent, quality is consistent, safety is present, and the end result is as consistent as possible. You now know what a work sequence is. Now, let's test our new knowledge by completing this challenge in the comments, upcoming assignments section, or on a piece of paper. Find a process you perform regularly and use a number format to write down your work sequence. Remember, we just want to see step 1, step 2, step 3, and so on. We look forward to seeing your work sequence here on Lean Strategies International LLC. Remember, by sharing your work sequence, someone may be able to help you make it better or help someone else improve. We look forward to seeing you back here in the next video. One-piece flow is not easy to achieve. In fact, it is very difficult to achieve. Nonetheless, it is the ideal form of flow for the just-in-time system. With that in mind, one must consider, what do I do if I have not yet reached one-piece flow? In this lecture, we will look at a very important piece of the standard work puzzle: standard work in progress inventory. Let's get started by first answering the question, what is standard work in process inventory? Standard work in process inventory is the minimum necessary level of items or materials needed to maintain the proper flow in a production environment. It would be impossible to create a standard work environment without understanding what the minimum amount of inventory you need on hand to keep the line flowing is. You would have bottlenecks, constraints, and issues all over. SWIP, or Standard Work in Process Inventory, is not the ideal. It essentially acts as a buffer of sorts so that the line can continue to flow if takt is not met or an issue pops up. The goal, of course, is to achieve true one-piece flow. But until then, SWIP will help keep the lines moving. Keep in mind that SWIP is calculated in many different ways, and while we won't dig into calculations just yet, you should note that if our work in process inventory is higher than our SWIP is set at, you will have excess inventory. If, on the other hand, you have less SWIP, then you will likely run out and bring work to a complete stop. With this in mind, we'd like to challenge you on this aspect of standard work by answering the following question in the comments section, upcoming assignments section, or on a piece of paper. At any given time, how much work in process inventory does your work area hold? We look forward to opening up this discussion with you all. And remember, this is just the surface of SWIP. In later lectures, we will dig into how it is calculated, when to add and subtract inventory, and how to progress towards one-piece flow. So, until then, keep on improving, and we will keep on giving you solutions that ignite your power. Cycle time is sometimes referred to as standard cycle time. Cycle time is the amount of time it takes to complete an individual operation or task from start to finish. In other words, the amount of time required to process one part. This includes processing time on a machine, any manual work that may be required, waiting, inspection, walking, and any other activities involved in processing the one part. Cycle time can be calculated with a stopwatch. In addition to calculating your cycle time with a stopwatch, one of the most common ways to calculate a cycle time is to clock the operations multiple times, for example, 3 to 5 times, and then use the average cycle time as your standard cycle time. So, how do you calculate your cycle time? Calculating cycle time is actually quite simple. First, you define your starting point. Then, at the starting point, you start your stopwatch. Finally, once the operation or task is complete, you would stop your stopwatch, and that's it. Another type of cycle time is process cycle time. This type of cycle time gives us the ability to determine whether or not a process is capable of producing the required quantity in the required time for the next downstream customer or process step. Keep in mind that each of the process steps is ultimately determined and controlled by the takt time. With this in mind, cycle time can sometimes produce quicker than actually needed. When a cycle time is quicker than it's actually needed, inventory builds up as well as many other forms of waste. If a cycle time is slower than the needed time, parts or information are not produced quick enough. This oftentimes will create bottlenecks, shortages, delays, and can even reveal other issues. Tools like Kanban and other process improvements can help an organization control the flow of production of materials and information. And that's it, cycle time. Now, before we go, let's test your new knowledge out. Go and get a glass and pour some water. What is the cycle time of you pouring your water? What was your starting point and what was your end point? You can write your answers on a piece of paper, comment in the comment section, or answer in the upcoming assignment section, and we'll see you in the next video. Many companies wonder, where should I start with my continuous improvement journey? And while the answer varies for everyone, in this module we will answer a key question that all organizations must consider. What is the foundation for continuously improving? Standard work is developed by people who actually do the work at the Gemba. They document the best known practices at the current time in an effort to set up conditions that allow them to improve later on. With that being said, standard work should never be the end of the improvement process. Rather, it is a starting point of the improvement process. Taiichi Ono once said it best when he coined the phrase, "Where there is no standard, there can be no Kaizen." This is true in the sense that only when standardization has occurred are we able to perform work the same way each time. When this occurs, we are better able to see the gap in what we are doing and what we would like to be doing. With this in mind, we all need to understand that standards are never the end. Rather, they are living documents that should be improved upon. So, much like a high jumper reaches a specific height and then inches the bar up, we should start with a standard and then inch our bar up again and again. With this analogy in mind, we can find the answer to the question, where should I start my continuous improvement from? Standardization is a good place to start. Once you have standards, the possibilities are endless. Now, let's end with a question that you can answer in the comments section, upcoming assignments, or on a piece of paper from your desk. In your current place of work, how are standards developed for processes and operations? And how are people able to access these standards? We look forward to the discussions that may develop from these questions, and we'll see you in the next video.